So good morning to all of you. Welcome to my lecture number 3. Myself M. Soundararajan, Assistant Professor from Agriculture Department of Agricultural Engineering at Sri Shanmugha College of Engineering and Technology. So in today's lecture, today we're going to see two important fundamental physical properties of the soil that are soil texture and soil structure. Soil texture, that is a permanent composition, and the soil structure is a variable arrangement. So in today's lecture, we're going to see detail in view of these two physical properties. Okay, we can move to next slide. Yes, as this slide is about soil texture, here I given the definition for soil texture. You can see in this slide. This slide introduces the concept of soil texture and its fundamental importance. Yes, soil texture is the classification of soil based on the relative proportion of its mineral particles like sand, silt, and clay. It is a fundamental permanent soil property that cannot be easily changed in the field. This texture determines key physical properties of the soil, including how well it retains water and drains, how much hair it holds, how easily it can be walked on the field, and its ability to hold essential nutrient retentions, and its erosion susceptibility. So, resulting that different combination of these particles result in various textural classes such as loam, sandy loam, or clay. So to found out the particular soil texture, we using the triangular soil textural triangle uh, to find out the soil texture of particular soil. So you can see in that in next slides. This slide introduces the soil textural triangle that is used to find out the soil texture of a particular soil. Yes, this slide introduces the official classification tool for soil texture. So the soil texture triangle is the definite tool used for soil classification. If the percentage of two separate is known, the intersection point on the triangle can be found to determine the official textural class. That means since the percentage of sand, silt, and clay must sum to 100 percentage, so knowing two automatically tells you the third one. If you know the two percentage of particles, you can find out the third percentage of your part, third particles. Okay, here I given the steps. I mean instructions how to read the textural triangle to find out a particular texture of the soil. To the percent of clay is read in horizontally in the triangle. The triangle is given in the next slide. And next, the silt is the percentage of silt is read diagonally from upper right to the lower left, and the percentage of sand is read diagonally from the lower left to the upper right. So we can see that the triangle in the next slides. Yes, here you can see the soil textural triangle on the right side, and left side I given the problem for your understanding. By using this soil textural triangle, we're going to find out the solution for this problem. First of all, we have to read this problem. A soil sample contains 58% of sand and 27% of silt and 15% of clay. So they are asking what type of soil texture that soil sample is. So here I giving the step-by-step solution procedure to find out the solution. I given the step-by-step procedure. Um, See, yes, actually this slide is step-by-step application of soil texture triangle. So first we have to do that. We have to find out that 58 percentage of the sand axis, that is at bottom. I will mark that. You can see this is the sand axis that is at the bottom of the triangle. Then we have to draw the line to right. But here one thing we have to change that. Here we have to draw the line which should be parallel to the silt axis. That is, it is the silt axis. Here is the silt axis, and bottom is the sand axis, and at left side you can see the clay axis. That is the clay axis. Yes. So we have to draw the line from 58 percentage to the uh, left side, because in the line you can see that draw a line to right side, but we can't write the right side because the sand percentage is 58 percentage, almost more than 50 percentage. So we have to draw the line which in this case to the left side from 58 percentage. Yes, it almost comes to this point, 58 percentage. Yes, you have to draw the line to the left towards the clay. This line, I can't draw this line exactly like scale by exactly. So I tried this to do, to make this line very straight. Okay, then we have to make the line from clay axis from the 15 percentage. It comes between the 10 to 20 percentage. It almost comes to this point. We have to next draw the line horizontally. The line I drawn is not exactly horizontal, but we have to we can use in real time. The scales we can use in real time. But in this, for your understanding, I draw these lines by myself. Then you have to draw the line from 27 percentage from the silt axis. That is at the right side. You can see that we have to start from upper portion, because you can see that the numbers are downwards from upper portion to lower portion. So here you have to find out the 27 percentage. It almost comes to this point. Then you have to draw the line towards the sand axis that should be parallel to clay axis. Yeah, now we can draw that. Yes, it intersects at a point. You have to draw the arrows that to denote that which direction that arrows going. It starts from this point to. Okay, so finally the intersection points located at sandy loam zone, that is in green color. So the given soil sample is called as sandy loam or loom sandy loom. So the finally the lines will intersect at the sandy loom. So the given soil sample is found as the sandy loam soil. So I think you got how we have to use this soil texture triangle to find out the particular soil type, soil textural type. Okay, then we can move to next slide. So in continuation of soil texture, we're going to see the three types of soil separates. Uh, First, the sand, silt, and clay. You can see I tabulated the three separates at right side, and their properties are tabulated. So first one is the sand and silt and clay. You can see in the slide. So this slide details the USDA classification of three mineral separates by their size and key properties. So this classification done based on the US Department of Agriculture, that's shortly called as USDA classification system, that defines the three mineral separates by their diameter. The first one is the sand, that particle sizes in diameter ranging from 2.0 to 0.05 millimeter. That is generally feels like gritty. and it has the properties like high infiltration, drainage, and low water and nutrient retention. And it at same time it has the good aeration because of the pore space can be higher in the sand soil. Then next one is the silt separate, that is sizes in diameter ranging from 0.05 to 0.002 millimeter. So this is generally seen smooth and silky like floors. Then it has the properties like moderate water retention and drainage, and often it is highly fertile because it has the high organic content nature. That's why it has the high fertility. So soils in having the silt separates generally called as fertile soil. The third one is the clay. These particle sizes in diameter can be seen less than 0.002 millimeter. These soils are, because of its size, it gives the stick and plastic characteristics when in wet condition. So it has the properties like low infiltration and drainage and very high water and nutrient retention due to high surface area. So these three separates are we have to the separates are uh, part of the soil. So we have to know these three separates. Based on this proportion of these separates presenting in the particular soil, it gives you a classification. It uses to classify a particular soil type based on these three separates present in that soil. Yes. So in this slide, we going to what are the determination methods using to find out the soil texture by using the field and laboratory methods. So there can be the texture can be determined using field and laboratory methods. The two methods is field method and laboratory method. The first one is the field method, that is texture found by field or ribbon test, and in the laboratory method we are using hydrometer and pipette method. So this slide provides visual for texture determination method. The first one is the field method, that is called ribbon test. You can see on the right side how the procedure is done using our hands. The visual illustrates the steps. First one is the you can see, add small amounts of water to small handful of soil and walking it to from near bowlers. The soil second procedure is the soil is at the appropriate moisture when the surface just glistens. Then third hand procedure is squeeze the bolus between the thumb and forefinger to form a ribbon. And in final hand, you can see that a clay soil forms a long and durable ribbon. For example, it might be 7 centimeter long. So that while a sandy soil forms a short and weak ribbon. For example, it might be in 1 centimeter long, 1 centimeter long. So clay soil gives the high lengthy ribbon when compared with sandy soil. The second method is the laboratory method. It is based on sedimentation process. The visual source below the slide, you can see the three types: the pipette and hydrometer method and ISP method. So the visual source three techniques for measuring the settling of soil separates based on the size, density, often relying on Stokes' law. You can see in this picture. I'm going to show round. So this is the ribbon method. See, it is the laboratory methods, different laboratory methods. You can see in the pipette, the sedimentation takes in between the uh, center of the. So in pipette method, you can see the sedimentation occur in a thin layer at the uh, beaker. Then you can see that uh, the sedimentation occurring in the hydrometer at the center, but it gives the not like thin layer in the pipette method. It gives us some band, some lengthy layer, gives a lengthy layer. Then at same time in ISP method, sampling tune is higher than that hydrometer. Okay. Okay, next we're going to see the topic of soil structure. So here before we seen the all things about the soil texture, but next we're going to move soil structure. The topic is soil structure. Yes, soil structure. There is the difference in soil texture and structure. Soil structure is the arrangement of individual soil particles like sand, silt, clay into larger clumps called aggregates or pits. So this organization creates the pore spaces between the aggregates which are crucial for water drainage, hair movement and root growth. So poor structure results in low crop yields and is difficult to manage. So aggregates form through three types of process like physical process and chemical binding through the biological action. So physical process aggregate formation occurring happening through physical process like freezing and thawing. Then through the chemical binding particles like calcium and magnesium are making the soil particles to combine. Then through biological actions by roots and fungi and bacteria and earthworms are the external agents that help in combining the soil particles to make the aggregates. So next slide we're going to different types of soil structure. Yes, you can see the different types of soil structure here. The first one is the granular. The main types are categorized by the shape of the aggregates. Okay, so the granular and crumb structure that are in rounded shape and small particles, so that has high permeability. And next one is the blacky structure. It is a cube-like shapes with either sharp or rounded corners. That's why it has the moderate permeability. And then it has the and then prismatic or columnar structure. It is the rectangular shape and prismatic having a flattened top and columnar having a rounded top. So these type of structures having the moderate permeability. And the next one is the platy structure. Plastic structures are in rectangular shapes with a long horizontal dimension like a stacked plates. So these type of platy structures soils having the low permeability. Then final one is the structureless. That soil has the no structure, specific structure. So the soil with no aggregation. This can be single grained or massive. So for example, for single grained structureless soil is the sand, and for massive structureless soil is the compacted soil clay. Yes, we can move to next slide. Yes, here you can see the different pictures of different types of soil structures. You can see I given it for your reference. So you can see that first one granular structure that has the high permeability because it having the high pore spaces within the two particles of the structures soil structure. So that pore spaces between the particles in the soil structures allowing the water to flow easily by the gravity towards the water table. So it seems like aggregated soil structures. So that also having the high permeability like granular structure. So it having the pore spaces between the soil particles. You can see I'm marking here. So it having the pore spaces. So from that spaces, air and water can move easily by the gravity. So here also granular structure, you can see this. I'm marking the dots for identifying the spaces between the soil particles. That the white colored uh, spaces between the particles in these pictures denotes that pore spaces. So these spaces making them the high permeable soil. The second one is the blocky and columnar or prismatic structures. You can see these pictures having the very limited or partial pore spaces when compared with the above structures like granular and aggregated. You can see that very little or small amount of pore spaces you can see. So at same time, in contrast, you can see the columnar prismatic. There is no or very little pore spaces have been seen between the two particles. So you can see that part if you assuming this particle 1, then if you are assuming this one is the particle 2, if you, likewise you can give the number to each particle. This one is the fourth and fifth. So the spaces between these the spaces between the particles, each particles you can see I'm marking that having that very low or small amount of spaces, that's why it having that moderate permeability. So in contrast to all these structures above, the plateau massive structures are completely not allowing the water to enter through it, because it act as opposite or opposite it complete it makes the complete block to water passage. That's why it having the low permeability. We can see that it is the continuous big layer, like you can see that soil particles having flat surface that completely blocks the flow of water when water comes from above to lower water table. I think I hope that you can understand that why they are having that particular permeability characteristics because of their structural arrangements. So that's why the structures also uh, defining or influencing the permeability and aeration of the soil. Okay, next we can move to next slide. So here we're going to see importance of good soil structures. Yes, it is a very important one. The structure already I told you that structure and textures are influencing the soil aeration and soil root growth, plant root growth and water infiltration or permeability of the soil. So this slide summarizes why a desirable structure is critical for soil health and productivity. So a well structured soil, typically defined by a strong granular crumb structure in the topsoil, is crucial for supporting plant life. So good structures achieves the ideal balance between two types of pore spaces, like macro force and micro force. So macro force means large spaces between the beds. These facilitate rapid water infiltration and drainage and excellent aeration. I mean, aeration means here gas exchange between the soil particles. Then next one is the microphores. Microphores are small spaces within the pits. These are vital for retaining moisture and dissolve nutrients. So this balance allows the soil to efficiently perform the four key functions necessary for agriculture, that are water infiltration and drainage, aeration, root growth. So root growth providing easy pathways and access to resource. So good soil structure providing the easy pathways and access to resource to the root growth. And a good soil structure creating a habitable environment for microbes and fauna. That's why it also influences the biological activity. So we can see the detailly the how soil structures influencing the water infiltration and drainage and the aeration root growth and finally biological activity. So the what a good structure is essential for managing water movement within the soil profile. A large interconnector macro force act as a channel or highway for water. So they allow the water to infiltrate to the soil rapidly and drain efficiently. This rapid movement prevents surface runoff and erosion. If soil in compacted or massive soil structure, macropores are completely destroyed. The next one is the aeration. So aeration is the process of gas exchange between the soil and the atmosphere, which is vital for all living organisms in the soil. So the macropores are not only for the water movement. When water drains away, they fill with air. So the supply of oxygen, I mean O2, to plant roots and beneficial soil microbes for respiration and allow the gaseous byproduct carbon dioxide to escape. So poorly structured soil, example plateau massive structured soils have a low volume of microphores. So leading to poor aeration and a buildup of toxic gases that can harm roots and suppress helpful microbes. The third one is the root growth. The soil structure determines the ease with which plant root can grow and explore the soil for water and nutrients. So a well aggregated structures like granular breaks the soils into discrete units like pits. Roots follow the path of least resistance, primarily growing through the macrophores that exist between these aggregates. So these arrangements provides easy pathways for root to penetrate deeper, ensuring the good anchoring and maximizing their access to both the air and the macrophores and water nutrients held in the microphores. So in massive or compacted soil structure, root face the immense physical resistance leading to restricted shallow growth and reduced resource uptake. The final one is the biological activity. So biological activity encompasses the life cycle of earthworms, fungi, bacteria, and other fauna. So that are fundamental to nutrient cycling and soil health. So good soil structure ensures the presence of both oxygen and moisture. So it also provides sheltered spaces and food resources. So this creates a habitable environment that supports a large and diverse population of microbes and fauna. These organisms are critical because their activity continuously help form and stabilize new soil aggregates, so perpetuating the good structure. Then poor structure can lead to anaerobic conditions. Anaerobic condition means lack of photo presence. So the poor structures creates the extreme drainage which kills off the beneficial organism and severely inhibits the decomposition of organic matter. Yes, I think you got understand about the importance of soil structures, how it influencing the different activities like water infiltration, aeration, root growth, biological activities that are occurring in the uh, soil. Okay, I hope that we can move to final slide. I hope that today contents are very useful for your uh, preparations for examinations. I will come with new topics in lecture 4. Until that, thank you for your listening. Bye.